In this video, we're going to continue discuss another concept about finding the cumulative distribution function of a probability distribution function of a discrete random variable. Okay, I repeat again, is to find the cumulative distribution function, the capital Fx here, which is the cumulative distribution function for the discrete random variable x. Okay, so this is the given probability distribution function. Alright, so okay, let's look at how I'm solving this question. So they are given that the cumulative distribution, so means the probability distribution, which they give you a table. The table consists of 3 probability, right? Or consists of 3 random variable. Okay, 3 random variable. So we have 0, 1, and 2. So 1 over 4, 2 over 4, and 1 over 4. As you know that the total probability here must be equal to 1, right? As this is a discrete random variable. So how to finding the cumulative distribution function for fx, right? And you must know that the cumulative distribution function of a discrete random variable is the sum of probability, which is x less or equal x, right? So means that it's a cumulative, right? The random variable before x. So let's see the way I finding the cumulative distribution here. All right. So you must see the patterns of how I'm doing finding the cumulative distribution function. So as you know that this is 0, right? So before 0, you have to start with the first one. Start with before 0. There is no probability. Means that the cumulative will be only no probability is 0, right? Before 0, there are no probability. There are no probability because start from 0, you have 1 over 4. Before 0, you have to write this. Before 0, there is no probability accumulate. All right. So secondly, after 0 means that it's already 0, but before 1, this is the pattern. Before 1, right? Before 1 means when start we count 0, but before 1 means that the cumulative will be px equals to 0, right? So which is 1 over 4, right? 1 over 4. This will be 1 over 4. So after that, 1, after passing through 1 means that this is already, then we have reached 1, means that have 1, but before 2. We have reached 1, but before 2. So the cumulative distribution, the cumulative will be px equals to 0. Cumulative means you add up the probability before, right? So which is px equals to 1, right? Px equals to 1. So which is I add up 0 and 1, right? Up to 1, all right? But not 2, all right? But not 2. So this is 1 over 4. The first probability plus with the second one, 2 over 4, which give you 3 over 4. All right, and finally, right, we accumulate again, right? So now we have reaching 2, but now we have reaching 2, but there is no number, there is no random variable after 2, right? This is unbounded, so which is before infinity. Alright, before infinity. Or the simplest form for this is actually you can just write x more or equal to, right? Means that x is greater or equal to after 2. So the cumulative distribution function will be px equals to 0, right? Plus with px equals to 1 plus with px equals to 2. Up to 2, right? So means that just now is 0, now is 0 and 1, and now 0, 1, and 2, right? You add up all the probability finally. So then if you add up, you have 1 over 4 plus with 2 over 4 plus with 1 over 4. You were getting 4 over 4, which gives you 1. Finally, you were getting 1. We start with 0 and we end with 1. This is a cumulative distribution function. We can rewrite this cumulative distribution function into a piecewise function, right? A function so which start with 0 and must end with 1. The difference between cumulative and probability distribution function is they will start with 0 and end with 1. So before 0, there is no probability. Before 0, there is no probability. After 0, means after reaching 0, but before 1, the probability is 1 over 4. Right, from here, 1 over 4. So after that, reaching 1, but before 2, right? 1 but before 2. So the cumulative fx, your big fx, capital letter fx now is 3 over 4. Is 3 over 4, right? And after that, we go for this. Means after already reaching 2, right? But before infinity. This one doesn't matter, alright? The most important is to know that x is greater or equal to, right? After 2 means 2 and after, right? 2 and after. If you add up all the probability, you are getting 1. Can you see that? You are getting 1. So this is your cumulative distribution function, alright? So this is the way we perform our addition. Okay, our way of finding the cumulative distribution function. Alright, I'm going to show you 2 videos about how to find the cumulative distribution function so that you can see the pattern here. So for now, I want to show you how to draw the graph for cumulative distribution function and what's the difference between the graph of probability distribution function and cumulative distribution function. Alright, let's see. Alright, at first I want to show you how to sketch the probability distribution function as you learned in the previous video. So now I just sketch in fast. So which is x and probability distribution function, right? This is probability distribution function. So as the probability here is 1 over 4, right? And 2 over 4, right? So the random variable consists of 0, 1 and 2, right? 0, 1 and 2. Right, 0 here start from 0. So okay, when 0 it will be 1 over 4, right? This is a probability distribution graph, right? So 2 over 4. So when during 1 the probability is 2 over 4, right? 2 over 4, and during 2 the probability is 1 over 4, right? It's 1 over 4. So this is the probability, the graph of probability distribution function. Right, so now I'm talking about cumulative, right? Cumulative. So let's look at the difference, how I'm drawing the cumulative distribution function. So this video objective is to let you see the difference, all right? Okay, and this is a cumulative px, or we can rewrite it as px less or equal x, all right? So then you have 0, 1, and 2, right? You can start 0 here, okay, 0 for cumulative, 0, 1, and 2, right? So, okay, follow the graph here, x less than 0, right? Less than 0. Less than 0 means, so there is an empty circle here, right? So the line, during less than 0, the fx is 0. Means that your fx, the y is 0. So means this is the line here, alright? I just thicken the graph, okay, thicken the line. So it's to let you understand that there is a line here, right? Where it is fx equals to 0. So between 0 and 1, 0 and 1 include 0 is 1 over 4. So we have 1 over 4. So I just write 1 over 4, 2 over 4, 3 over 4, and finally 1. Alright, you see 1 over 4 plus with 1 over 4 plus with 1 over 4 plus 1. Okay, so later on you see between 0 and 1, follow this, alright, cumulate 0 and 1. So it's 1 over 4. So it's 1 over 4 is here, right? Between 0 and 1, this is 1 over 4. So for here, I will solid circle, right? Put a solid circle. And here I put a empty circle, alright? Empty circle. Alright, then this is for this function at this particular interval. So now it's between 1 and 2, right? Between 1 and 2, right? So between 1 and 2 is 3 over 4, right? Between 1 over 2 is 3 over 4. So it's from here to here, right? 1 and 2 is 3 over 4. So 3 over 4, so for this is include 1, right? So means that this one will be solid circle, empty circle. This is the way we drawing cumulative distribution function graph. Okay, the graph for cumulative distribution function. This is the way. So now after 2, right? After 2 means that after 2 means that 2 and beyond, right? It will be 1. We're drawing this way, right? So if you see that the graph, they're going step by step, right? Like a staircase. Okay, now, so it's from 0, adding become 1 over 4, 3 over 4, and later 1. So this is the way we're sketching the cumulative distribution function graph. Very important. If you're not very understand, I will do another video for you. All right. Hope you understand. And from this cumulative, right? This cumulative, we actually can put it into a table. All right. We can write the cumulative distribution into a table. So, for example, all right, we can put the cumulative distribution function into a table, right? If the question is asking you to doing that, all right, they may asking you to construct a cumulative distribution table, right? Just now they asked about cumulative distribution function, so it's a way to finding the function, right? So if cumulative distribution table, the meaning here will be fx. So for cumulative distribution table, so we have 0, right? 1, 2, all right? Oh, sorry. So we just need 3 columns. So for this, we have 1 over 4, followed by adding up 1 over 4 plus with 2 over 4, we have 3 over 4, and finally we have 1, right? We have 1. So through the cumulative distribution table, we actually can identify the median, right? Median, or from the graph we can identify the median. Very easy. So it's a probability that more than 1 over 2, right? More than 1 over 2. For example, you look at this 1 over 4. 1 over 4 is 0.25, right? Probability, when we said about median, right? Median. So median must be half of the probability. Means that the total probability will be 1, right? So means that the median will be 1 over 2. The probability must be 1 over 2. So means that the median will be 1, right? Will be 1. Because why? This is the number greater 0.75, right? Which is greater than 0.5 for the first time, right? So means that the median here, the median for this case will be x equals to 1. So through here you can see that so it's 1, right? 1 greater than 1 over 2, right? So during 0, during 1, right, is greater than the cumulative is greater than 1 over 2, right? But this is 1 over 4 only, right? So very easy. If they're asking to find the median, this will be your median. All right, 1. So I will show you another example in the next video to let you understand the way of finding the cumulative distribution function. All right, I think that's all for this video.